Hi guys, this is KVS. Today let's talk about what is a virtual threads, which was introduced in JDK 21. And also we do have the other framework supports like Spring Boot with the Spring Boot 3.2.0. So let's talk about what is a virtual threads and what is the advantage with the virtual threads. Before even we talk about virtual threads, so first of all, we should know what is the thread per request model. Let me bring the slide and share me the screen. Okay, so here are the, basically the thread per request model. Assume that, we have a web application. It could be any Java or Spring Boot application. Maybe we have a multiple clients. One could be mobile, web, and other clients, or it could be other application which is accessing the application. So that application might be talking to the database, or it could be any HTTP call. So what generally happens when the request comes to the application, and when the request goes to the any of the blocking calls, could be DB or it could be API calls. So the thread is going to wait until we get the response. So basically the thread is going to block, meaning for each request, so we are going to block the thread until we get the response back. Assume that we have the server. Maybe the server has some CPUs. So if you check, this particular Mac system, if you go to the about this Mac, let's go to the more info and see how many CPUs we have here. So let's go to the system report. Yeah. So here you go. So we can see the total number of CPU cores are 88, meaning so we can have only 8 OS threads and 8 platform threads, right? So either, our application can have only 8, the threads can be created. So these are the parallel threads. So we cannot go beyond 8, the parallel threads. So now, if we go to the slide again, so now assume that we are getting maybe some hundreds of parallel requests. So when we get hundreds of parallel requests, what we basically do, so the each request goes to the, these API calls or database calls, and the request is going to wait until we get the response. So for each thread, definitely we need to have some stack. So maybe it consumes some memory for creating a thread and getting the response back to the user. So we need to wait until we get the response. So now the thing is, so we may be getting a millions of requests. So definitely we cannot serve all the requests. So we need to go for kind of a imperative, the programming style. That's nothing but the reactive Java programming. We do have the reactive Java programming using the Spring Webflex project reactor, or even we can also go with the thread pool executor. So the way we write the project reactor using the Spring Webflex, it's going to be very complicated and it's not so easy to understand. So the imperative style of programming is completely it uses the lambdas and functional programming. So it's very difficult to understand and it's very difficult to debug it. So that is where people are started migrating to the Webflex reactive, and we need to use all the reactive stack. It could be any database calls or anything. So that should support the reactive stack. So now, if you want to make a call to the API, so definitely we are going to use the web client. So the web client basically it supports both the synchronous and blocking calls. Whereas, So this is what, assume that I have a 8 OS, the CPU cores. I can go for max 8 threads. Definitely the platform threads, which is created by the Java application, also can have 8 threads. So, 1:1 between the platform and OS thread. So now with the virtual threads, so assume that we get a millions of requests. So the each request, first it will not create any platform thread. So first the request goes to the the virtual thread. So whereas it needs only the bytes of memory in order to create a virtual thread. And we can create a millions of threads, the virtual threads. So whenever the request is received, instead of first creating the platform thread, first it creates the virtual thread. And then whenever any platform thread is available, it assigned to the corresponding platform thread. So once the request is served back to the user, so again, it takes any request and, go to the platform thread, and again, it processes the request. So here, basically, instead of, the request directly goes to the platform thread. So here, first, the request goes to the virtual thread, and the request will be served to the corresponding user request. And it's the virtual thread, it's kind of it internally uses the fork join pool, where whenever any thread is available, it's going to assign that take that particular thread and execute the request and respond back to the user. So now let's see how we can use that programmatically with the Spring Boot application. I'll be talking about in terms of the Spring Boot application. Let's see the demo, how we can make it work. So I'm going to create two Spring Boot applications. One is going to be, let's say, demo 1. So let's choose the Maven Java, and we need to have a Spring Boot 3.2.0. That's a minimum minimum Spring Boot support version. And we need to have a JDK 21 because from JDK 19, we have the preview version, and officially it was launched as part of the JDK. Let's create the group. Let's make it as a com.kvs, and even the package, let's make it as the com.kvs. Add the dependency, only the web dependency. We don't need any other dependencies in order to enable the virtual threads. So let's generate this. I'm going to create one more application. That's the demo 2. Let's generate this application as well. So now we have 2 applications generated. Let's extract this 1 and then 2. So both applications are extracted. Now I'm going to import this into the workspace. Let me import it. Yeah. So now the demo 1 is going to import. Let me pull that into the here. Yeah. So now we have the src main Java. Let's create one controller, and with the one simple get endpoint. Let's say, yeah, here, let's make this this class itself as a controller. And I'm going to create one get mapping, and then let's say app1. So public string app1. So this is the response from app1. And I wanted to block some, block for, let's say, sleep for 1000 milliseconds. Okay, just to see, how many threads I can create and how much time each request is taking. So now I'll make this as a YML file because the IntelliJ, the free version doesn't have the property support directly. So yeah, now server.port. Let's make it as the 9002. Yeah, run this application. So this is not the virtual thread. It is the simple Java application with the blocking. So now the application is, one is about to start with the port 9002. Yeah, it is started. Let's import the other application. This is the demo2. Let me pull this into this. So now here we have src main Java. Let's make this also as a controller, REST controller. Here, basically, I wanted to call the demo1 API endpoint, which is the app1. So I'm going to create a one more endpoint, app2. So which basically returns the response from the app1. Here, I don't want to put any sleep because I'm going to make a the blocking call, which is the external API call. So in order to make a call, we generally use either REST template or web client. So now with the REST template, since it's going to be deprecated, we are not going to use anymore. And the web client, basically it supports both synchronous and asynchronous. Either we can use the web client. In this case, since we are not yet started on the virtual thread application, but I'm going to use the REST client, which supports the virtual threads. REST client is similar to the web client. So REST client.builder.build. So we can have the base URL. So the base URL is going to be http localhost 9002/app1. So this is my base URL, and this one itself is a URL as well. So I can directly use the REST client.get.retrieve, and then we have a two entity. So I wanted to return as the response as the string. So this call is going to return the string response entity of string response entity. So now if the response status code is successful, then return the body. All right. So else, so response from app2. So this is what my API call. Now let me make this properties also as the YML. So let's have the server port 9003. Right. So now we are good to start this application. So this doesn't have any kind of a virtual threads enabled. It has the simple Spring Boot application, which makes a call to the another application. So this is basically going to be the blocking call. Let's start this application and verify some performance or the benchmarks check. If you're using any Linux or Mac, so there is something called Apache benchmarks. So before that, just to verify the response, I also wanted to print the thread name. Let's print the thread name. Thread dot current thread dot toString. Let's restart this application. Once the application is restarted, let's go to the http localhost 9002/app2. So this is the app2. Okay, it's a 9003. So let's make it as 9003. Hopefully we should get a response in a second. Since we have the the sleep time as 1000 milliseconds. So now this response is coming from the API 2, but again, the call goes from the API 2 to API 1, and we get the response back to the API 2. So this is the, with the blocking. Let's do some kind of, the benchmarks check. So what I will do is, there is something called AB minus N. AB is nothing but, the Apache benchmarks. This supports only the Windows and the Linux. If you're using Windows, I think you might have, it supports only Linux and Mac. So if you're using Windows, I think you might have to install something, or there might be some other tools available. So AB minus N, you can also use the Apache JMeter as well. So minus N, I want to create a total 10 requests, and let's make us a 100 requests. Each time, let's say 8 parallel calls, all right? And then HTTP localhost 9003/app2. So now it's making a call to the application. If at all, if you want to see the log. So when the request goes to the service 2, so still it is initializing. Generally, we supposed to get this log. Let's see, did we miss something here? Yeah, HTTP. This looks fine. Why this log is not generated? Yeah, because we are returning it, right? Let's print this current thread even before, just to see what is the the current thread name. I'm going to restart this application so that when we make a performance bench call, the Apache bench, so we should get the thread name as well in the logs. So now the application is started. Now test it, AB minus N 100, and then minus E, and how many, the parallel calls, 8, right? So now, so we can see, so it's all the main thread. You can see, right? It's all, the main thread is created. Okay. So this looks good. But again, so we have limitations. So now if you want to make, multiple calls, could be batch of list of list. It could be batches in parallel. So, either we have to use the thread pool executor, or even we have to use the asynchronous programming using the Spring Boot Web Flex with the project reactor. So that's going to be very difficult to understand. So now, so what I will do is I'll go with the virtual threads, right? So virtual threads, if you go with the big number, so definitely we see a lot of failures with the, without virtual threads. Now let's enable the virtual threads. We have a property called Spring Thread Virtual Enabled is true. By default, it is a false. When you enable it as a true, so it is going to enable with the virtual threads. Let's restart this application. So now application is restarted. So for the previous one, if you see, so the overall, it took 15 seconds. Let's try the same exercise with the virtual threads enabled. It is still executing. So yeah, so the first one and second one, it took almost the same. The reason is we don't have any kind of, the parallel calls. It's all, the C, we are making the same number of parallel calls, right? So now, if you increase the number of parallel calls, let's make 20, and let's make this as a 200. Let's make it as 100 and see how long it's going to take. Yeah, you can see now. So the time is reduced to 6 seconds. The reason is whenever the request goes, first the request goes to the virtual threads, and then it takes any of the availability thread by using the fork chain pool, and then the request will goes to the OS thread. Finally, it serves the response back to the any of the the available thread, and the response will back to the as from the API response payload. So that is the the virtual threads. If you want to see how the virtual threads are created, even we can see the name also, virtual thread name. Yeah, so you can see the thread name is it's a virtual thread, and internally it is going to use the fork chain pool and with the worker. So that is how the internally it is going to use. So if you wanted to check from the J console whether really it is creating the virtual threads or not, there are a lot of tools are available. There is a machine control, and by using Java machine control, and we do have the J console, and there are a lot of tools are available. So demo 2 application. Let's connect to the demo 2 in secure connection. So let's go with the the threads, and then let's make a call now and see what's going to happen. Let's make 1,000 requests and 20 parallel. So you can see the number of fork join pools it is creating, because whenever we get a request, it creates there are multiple things. So first it creates the HTTP client, and then it goes to the virtual thread, and then it uses the fork join pool in order to assign to any of the available platform thread, right? So this is how basically we are going to use the virtual threads. So there are limitations with the virtual threads. If you are using virtual threads, basically, if you have any kind of a synchronized block or any synchronized or even thread locals, it's not going to support. You will have to avoid if you wanted to support the virtual threads. So that's all, guys. Thank you so much for watching this video. Please do subscribe and share it with your friends.